In this demo, we'll show how a business user's request for an AI-enabled data analysis environment is delivered using Cloudera. Our business user, Kamari Ellison, is a deputy administrator at the Department of Transportation. She oversees investigations into flight delays and is responsible for delivering pre-penalty warnings to responsible parties. She starts by submitting a JIRA ticket request for a dashboard which will help her understand which flights are delayed the most. This request lands on the desk of a data analyst, Morgan, who starts by searching for data in Snowflake. In Snowflake, they can see some of the data elements they'll need to fulfill this request, but they'll need more data. For this, Morgan will turn to Octopai. In Octopai, they can see what other data elements they need in order to make this happen. Morgan will do a search and then investigate the cross-system lineage for data that can supplement what they retrieved on Snowflake. Right away, they see an Iceberg schema. It came through NiFi. An ETL process was written from Spark to an Iceberg table. Since this data is in the Cloudera data lake, it's not accessible from the Snowflake environment yet. Morgan will request access from Cloudera Platform Administrator Casey, who is going to log into the Cloudera data catalog and grant them access. The data is already published to the Iceberg REST catalog, but now it needs to be shared so that the external engine can access it. Using Cloudera, Casey creates a new data share to make that happen. They'll provide a name for the share and can specify other details about what will be shared, such as a summary and keywords or tags to aid with discoverability, along with policies that define a time frame for the share to be active. Then, Casey will select which assets are to be shared, such as the flights table. Next, they'll provide the information about which user should receive access to this data. Today, they'll register Morgan, our data analyst, as a new user that will be accessing the shared data via Snowflake. In the Cloudera data sharing workflow, additional supplementary documentation can be added, such as the description of the data or a contract defining its use. Casey will review the share details, then create the share, before confirming that the share should be published. Once he has done so, Morgan should now have access to the table via Snowflake. Morgan can now confirm that they can query the flights table from Snowflake. Right away, they'll see the share event and that they have access to a new flights share table. This is the Iceberg table that was shared with them using Cloudera. After a refresh of the table browser, Morgan can query this table successfully. But data analysis is rarely that easy. Morgan discovers they still need more data to fully answer the business question. A data engineer, Llama, is brought in the project to assist. Llama turns back to Octopai, this time to discover that there is a table in Impala that is relevant to answering the business question. This table contains capacity details for each flight that was delayed to help determine the impact of the delay. Llama will turn to the Cloudera data warehouse to query across these multiple data sources. Within Cloudera, Llama will open the Hue SQL editor and use the Trino Query Federation engine to query data from the Impala and Snowflake with a single query. The Hue SQL AI assistant lets them create the join using only a natural language prompt. This SQL AI assistant is leveraging the power of Llama 3.170b, a large language model deployed via the Cloudera AI inferencing service. Using a private model deployment such as this one means that no data is leaving the VPC, so Llama has the assurance that it's safe to leverage AI for this purpose. This AI assistant quickly produced a SQL statement that can be imported into the editor. When Llama runs the query using Trino, it seamlessly returns joined data from Impala as well as Snowflake. This query can now be used as the basis for a dataset in Cloudera Data Visualization and will be able to give our business user access to the data they need. When Kamari has access to the system with the data she requested, she'll use Cloudera Data Visualization to ask natural language questions to build visualizations. Cloudera Data Visualizations running in Cloudera Data Warehouse is connected to the same Trino warehouse as Hue, so each visual is sending a multi-database query seamlessly, and the business user will have no difficulty discovering the data that they need. Kamari asks first which airports are the most delayed. The visual response she receives can be saved to a new dashboard. Then, she'll ask which airlines are the most delayed. The second generated visual can be saved in the same dashboard. That dashboard is automatically saved to a workspace where it can be shared with other users, customized further, and referenced for further analysis. Once she opens the final dashboard, it brings together a unified view of the data into a central location. As a business user, Kamari can quickly and easily zoom into a map visual or explore bar and line charts that answer her questions. This dashboard will let her drill down into the key data points to make proactive, data-driven decisions. Right away, Kamari will spot a location which will be the focus of her investigation. Adak, Alaska, an airport located at the westernmost edge of Alaska, is home to the most delayed flights in the country. Let's recap. We saw how a business user's question journeyed through a pipeline starting with data discovery using Octopai into a data sharing workflow across systems, and then a multi-database query using Trino. Along the way, Cloudera's powerful AI assistance in Hue and data visualization reduce the effort it takes for analysts and engineers to interact with the data. When we return to Octopai, we now see the full lineage. Here we can see where it started with a NiFi ingestion from a SQL Server table, followed by all the ETL processes that preceded visualization. Details about every movement of data, from the Iceberg table share to the data residing in Snowflake to its use in the final BI dashboard, is all visible in this end-to-end column-level lineage. This was all possible with Cloudera and Octopi.